Okay, so we're going to talk about section 3.2, which is on solving quadratic equations today. Uh, and so we're dealing with the same quadratic equation that we had before. And in general, our approach is going to be to get that standard form quadratic equation equal to zero to solve that. And really, what we're doing here is we're trying to find the points where our quadratic equation crosses the x-axis, right? And remember, we talked about this a little last time. There's kind of three cases you can run into in this scenario. You can run into a case where your quadratic crosses the x-axis like this, which is going to give us two different solutions, right? We can also run into a situation like this where our quadratic equation never crosses the x-axis, which will give us no solutions. And then finally, we can run into this is kind of the least common case, but we can run into the situation where our quadratic equation touches the x-axis but doesn't cross it, and we have one solution. So this is the thing that's a little different about this scenario versus the linear equations. You'll always have one solution to a linear equation in almost every case, right? But with the quadratic equation, you can have two solutions. You can have one solution, or you can have zero solutions. Okay, the other thing to remember here in this lesson is that while we're going to talk about several methods that are going to let us solve these quadratic equations by hand, you can always check your answers by just graphing the equation that you're working with in Desmos and then just looking for the points where it crosses the x-axis. Now, there's a few limitations to this that we'll address later, but remember, we can check our work by just graphing those functions in Desmos and finding where they cross the x-axis. That's all we're doing here. Okay, so let's get started with our methods for solving quadratic equations. The first one is one that you probably learned in high school, maybe, but most people, in my experience in this class, don't remember it very well. Okay, and so uh, and that is a method called factoring. So we're going to solve this first one by factoring. And just in my experience teaching this class, most people don't remember this very well, but it is a very quick and efficient method to solve it if you remember the process. So I'm going to do one or two problems by factoring, but I'm not going to spend a ton of time on it for a couple of reasons. The first reason is that it just doesn't always work. Most quadratic equations are not factorable. Okay, you have to have a kind of a special scenario in order to be able to solve it by factoring. Okay, and uh, so I'm only going to solve by factoring simple quadratic equations. So this is an example of that. The thing that makes this one simple is the fact that our a value, our x squared coefficient, is a 1. If it's not a 1, I'm probably not even going to pretend like I'm going to solve it by factoring. Okay. There are other methods, like there's a method called the AC method that you can use to factor these things, but it's just more complicated than we're going to get into in this class. We'd prefer to use a different method. So this is a good example of a problem that I would attempt to solve by factoring because it's simple. My a value is a 1. Okay, so the other thing I'll mention before we get into this is there's a lot of different strategies that teachers use to solve by factoring. I'm going to have my method probably slightly different than the one that you learned from your previous teachers, right? Everybody has this look a little different, but I like to use a method that uses kind of a big X over here to help me keep things organized. Okay, you don't have to do that. If you have another method that you've learned from a previous class, you don't have to do that. Okay, so if I'm going to try to solve by factoring, what I'm going to try to do here is I'm going to try to find two numbers that multiply to give me my C value. So I want two numbers that multiply to give me 8. I'm going to put that on top here. And then I want those same numbers to add to give me my b value, the middle number, the number on the x. So I want two numbers here that multiply to give me 8 and add to give me positive 6. Okay, and so to figure out those values, I'm just going to look for pairs of numbers that multiply to give me 8. And there's really only a couple of options, right? If you want to get a positive 8, you either do 1 times 8 or negative 1 times negative 8, right? And 2 times 4, or -2 times -4, right? So there's really only four possibilities here. I can write those negative ones down too, because there's only four options in this one. That's why this is a good candidate for factoring. And then we're just looking for a pair of these numbers that add to give us the value on the bottom. So +2 and +4 are the ones that we're looking for. And so I'm going to put those on the side of my x here. Okay, so that does everything we want. 2 times 4 gives us +8. 2 plus 4 gives us +6. Okay, so then what I'm going to do is, because this is a simple quadratic with that 1 in the front, okay, I'm just going to take this, I'm going to break it down into two sets of parentheses. And I know that x times x is going to give me the x squared in the front. And then I can just put those two values from our x into those parentheses, and that'll give me the factored form of this quadratic. Okay, and if you don't believe me, you can always FOIL this out and you'll get right back to that original quadratic equation that we started with. Okay, and so if we can get to this point where we have this is in what's called factored form now, getting the solutions is quite simple, because if you think about it, we're multiplying these things together. So if this is equal to 0, just this first factor is equal to 0, it doesn't matter what the second is equal to, because 0 times anything will give us the 0 that we want. And you can use similar logic for the second one. If this is equal to 0, it doesn't matter what this first factor is equal to, because 0 times anything gives me the 0 that I want. So our method here is just going to be to take these factors and set them equal to 0 separately. Okay. And I'm going to wind up with two solutions, not surprising at all. We just are dealing with this case where our graph crosses the x-axis. So my answers here are going to be, these will just be little linear equations to solve. So quite straightforward. And so my answers here are -2 and -4. Okay. So you do have to be a little careful when you're trying to solve by factoring. Let me just make one change to this equation and we'll take another look at it. And say we do something like this. Change that +8 at the end to a -8. Okay, now if I try to factor it, I'm going to take the same approach. I'm going to set up an x. I'm looking for two numbers that multiply to give me that c value. So multiply to give me -8 and add to give me +6. Okay, and so when I'm multiplying numbers to get -8, right? Now what I know is that one of them needs to be negative and one of them needs to be positive, right? So my options here are slightly different. You can have -1 times 8, that gives me -8, right? Or I could have 1 times -8, that gives me the -8. The only other option here are -2 times 4 or 2 times -4, right? And when I add these numbers together, right, -1 plus 8 is going to give you +7, -7, +2, -2. None of these are going to give me that +6 that I'm looking for. So even though this is a simple quadratic equation, right, and trying to factor it is perfectly reasonable, it's just not going to factor. This cannot be factored. Okay, and that tells me one of two things. It does not tell me that this equation has no solutions. Okay, it tells me that this equation has no nice solutions. Okay, I'm either going to get no solution, like this case up here, or my solutions are going to be more complicated. They're going to have a radical in them, possibly. They're just not going to be nice. Okay, so that's why we're not going to spend a ton of time on factoring, because first off, most people don't remember it very well. Second off, many quadratic equations that have solutions do not factor. This is a perfect example of that. This one does have solutions. It just doesn't factor. Okay. So we won't spend any more time on factoring, but that's just a quick review if it's something that you remember, because it is, for this equation up here, it's the quickest and simplest way to find those solutions by hand. Okay, so the second method for solving quadratic equations that we're going to talk about today is this thing called the square root method. Okay, and this one is very powerful, but limited to where we're going to use it. We're only going to use the square root of method, or sorry, the square root method when our b value is equal to 0. That means we're missing the x term from our quadratic equation, right? So this is another quadratic equation. Okay, we don't have that x term. Okay, and so what this means is that it's going to be pretty easy to solve this equation for x squared. So like in this case, very straightforward. I just move the 4 over to the other side. I get x squared is equal to 4. Okay, now a lot of people will look at this and say, oh yeah, this is obvious. The answer is 2, right? Well, that is one answer, right? But if you think about it, if you plug a -2 into this equation, -2 squared is still going to give me +4, isn't it? So if I have an equation like this, the approach I'm going to take is I'm going to take the square root of both sides of this, right? And then in order to get all of my answers, right, because this was squared, I can have either a positive or a negative value on the other side. So when I use this square root method, that's the big trick is I need to take the square, solve for the x squared, take the square root of both sides, and then I can't forget that I'm going to have multiple answers here. I'm going to need to put this plus or minus on it. And then, the square root of x squared is x. I've got that plus or minus on there. The square root of 4 is 2. And so really this means I'm going to have two answers, 2 and -2 for my x values there. Okay, so when we use this square root method, those are going to be our steps. We're going to isolate the x squared on one side, do a little algebra to make that happen. Okay, then once the x squared's by itself, we're going to take the square root of both sides, and we're not going to forget to put the plus or minus in front of that uh, right side square root when we get there. Okay, so let's do another one. Let's do one that's slightly trickier. Let's say we have something like this. So 9x squared minus 16 is equal to 0. Okay, so again, my first step doesn't change. My goal here is to get the x squared on one side by itself. This one's going to take a couple of steps to make that happen. I'm going to start the same way. I'm going to move the 16 over to the other side. And then to get rid of that 9, it's multiplied, so I'm going to divide it. And so we'll have x squared equals 16 over 9. So first step, get the x squared by itself. That's done. Next step is once that x squared's by itself, I'm going to take the square root of both sides. And then don't forget, anytime you take the square root of a x squared like this, you have to put a plus or minus on that right-hand side in order to make that work. And again, the square root and the squared are going to undo each other. Just leave us with an x by itself. And then this one, again, works out pretty nicely. Not all of them will work out this nicely, but when you have a square root with over a fraction, you can just do the square root of the top and the square root of the bottom separately. So this is the same thing as the square root of 16 over the square root of 9. Square root of 16 is 4. Square root of 9 is 3. And so we get, 4/3 and -4/3 as our two answers. And again, we've seen how this is not an uncommon, I mean, this is something that we expect fairly often. We expect to get two answers from this. Okay. Uh, and then the last one we want to look at here is one where where we don't have a perfect square in there. Okay, so something like this. We won't do a ton of this. I don't think I'm going to put any of these on the exam, but you will have one or two in your homework. So we want to be able to deal with them for that purpose. Okay, so in this case, we're going to start the same way. Like I'll move the 27 over the other side. My goal here is to, again, isolate that x squared on one side. Okay, then we're going to take the square root of both sides. Okay, don't forget we have to put that plus or minus on that other side over there. These are going to cancel. Okay, and then if you try to put the square root of 27 in your calculator, it's going to give you a bunch of decimals. This is an irrational number. It's not going to work out nicely like the last couple have. Okay, but what we need to do in order to get this answer correct is we need to try to simplify this radical. Okay, and 27 is not a perfect square, but the number 9 is, right? So 27 is the same thing as 9 times 3, right? And 9 is a perfect square number, right? So we can rewrite this as 27 is the same thing as the square root of 9 times the square root of 3. Why is this important? Well, because we can simplify the square root of 9. The square root of 9 is equal to 3, and then the square root of 3 is not something we can simplify, right? It's just not a rational number. So we can bring that down. And so square root of 27 is considered to be more complicated than 3 times the square root of 3. So we do want to kind of clean it up like this. Now, again, this is not something I expect to put on the test. This is something that's more important for people going into science, calculus classes, things like that, right? We see this more in those types of situations than we will in this class. And so I would not expect to have to simplify a radical like this on the exam, but you will certainly have to do some fairly straightforward ones like this on the test. So the trick here is just to ask yourself, are there any perfect square numbers that go into that 27 evenly? Just a quick list of some of the perfect square numbers, right? 1 squared is 1. Uh, 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. 4 squared, 4 times 4 is 16. You'll notice they do get kind of big kind of quickly, 25, 36. So those are the numbers we're looking for. And then, of course, the list continues. 7 squared is 49. 8 squared is 64. And so we're looking for perfect square numbers that will go into our number under the radical if we want to try to simplify it. So that's the square root method. So let's move on. We'll talk about the big one. The one, if we're solving by hand, this is the one that always works, right? We don't have any requirements for that. So we'll move on here in just a second. Okay, so the next thing we're going to talk about is the quadratic formula. And the quadratic formula is powerful and important because unlike the other two methods that we've discussed here today, this will work for any quadratic equation. It will always find the solutions if they exist. Okay, so the first thing we need to note is when we want to use the quadratic formula, we need to get our quadratic equation into standard form. That's what this ax squared plus bx plus c equals 0 equation looks like. We call this the standard form of a quadratic equation. Okay, then we can just use this formula, and it's a big formula. Okay, hopefully you've seen it before from maybe a high school algebra class or something, but uh, you will not have to memorize it on the exam because I'll put it on the board, right? But you'll definitely need to know how to use it. And I'm going to give you a bunch of tips today on how to use this most effectively. Okay, a couple of things you want to make sure you're noticing here is that the fraction bar goes all the way across here. This negative b is on top of the fraction bar. That's important if you're going to try to put this into Desmos or something. You need to make sure you have that negative b on top of the fraction bar. Okay, the next thing you notice is that b is squared, right? And when we square a number, whether it's positive or negative, 2 squared is 4, negative 2 squared, negative 2 times negative 2 is also 4. So in order to get this correct, especially if b is negative, you need to make sure you put it in parentheses. Okay, we'll talk more about that in a minute. Minus 4ac. All of this stuff is underneath the radical here. We have a square root in this formula. There's nothing we can do about that. It's going to be in there. And then 2 times a goes down in the denominator. Okay. Now, if you do want to memorize this, there's a ton of different ways. There's like a bunch of, like if you go to YouTube, you search for quadratic formula song, there's a bunch of different quadratic formula songs that'll help you memorize this. Pop Goes the Weasel is the classic, but there's a Rolling in the Deep Adele cover that is the quadratic formula that can be pretty good to memorize this. But if you do want to memorize it, there's lots of tools available on YouTube and things to help you remember it. But again, you won't have to have it memorized for the test because I'll certainly give it to you on the board. Okay, so let's just get into this and practice making this work. Now, a little different than the last one. You'll notice this one we do need A, B, and C. We can't just get away with just kind of thinking about what the A and B values are, like we did when we were finding the vertex in the last lesson. Okay, so if we want to use the quadratic formula to solve this equation, it's a good choice because I'll tell you this does not factor. We could not solve this with factoring. There are not two numbers that multiply to give us -2 and add to give us +3. Okay, so if I want to use the quadratic formula to solve this, I'm going to start by getting my values. My A is my x squared coefficient, nothing written there, so its value is 1. My B is 3, and my C is -2. Okay. So I'm ready to plug into my formula. So we'll bring this down here. I want the opposite of B. Again, go ahead and draw your big fraction bar all the way across this thing. And then whatever b is, we're just going to change its sign. So b is 3. So I'm going to start with a -3. I have this plus or minus in here, which is how we're going to get the two answers that we often get when we're dealing with these quadratic equations. Okay, we want b squared. Okay, my advice is always put b in parentheses. Okay, now disclaimer, it doesn't really matter if you put those parentheses in there when our b is positive, like we have in this case, but it's a good habit because it matters very much if your b value is negative. Okay, so we'll continue on. -4 times a is 1 times c is -2. Again, I'm putting those in parentheses. Okay, all over 2 times a, which is 1. Okay, next, I'm going to go ahead and evaluate everything that's underneath the radical. Now, if you want to, and it's not a bad idea at all, just go ahead and take this whole thing, this whole 3 squared minus 4 times 1 times -2, and type it directly into Desmos. It's a very good idea to just put that right into Desmos exactly as it appears there. Just to show you what that looks like, let me uh, pop over into Desmos here. Whoops, not on the Desmos screen. Oh, here we go. So I would just type it in, or you could put it into any calculator, but I would recommend just putting it into Desmos. -4, or sorry, 3 squared minus 4 times 1 times -2, and it'll just work it out for you. Okay, so this is equal to 17. So I've got -3 plus or minus the square root of 17. On the bottom, we can usually just do this multiplication. 2 times 1 gives us 2. Okay, and now we want to try to clean this up. Okay, but 17 does not have a nice perfect square, and it also doesn't have any perfect square factors. The only way to make 17 with multiplication with nice numbers is 1 times 17. So this is our answer. Okay, we're going to get two answers. -3 plus the square root of 17 over 2 is our first one, and -3 minus the square root of 17 over 2 is our second one. We just break that plus or minus up into two separate answers, and then this is what MyMathLab is going to want on this kind of a homework problem. Okay, we're going to have two separate answers. We're going to separate them out with a comma like that. Okay. All right. So, and it's important that you're able to do this with the quadratic formula, because watch what happens if I try to solve this using Desmos in our uh, and our window here. Let me just get back to a new window. All right, so let's put this function in there. So let's say we have the equation x squared plus 3x minus 2. Okay, and what we're looking for here, what we're finding in all of these cases is just these 2 points where we cross the x-axis. And you'll notice here, what this is going to give us is it's going to give us a decimal approximation of this solution. Okay, so -3.56 and 0.56, right? This is the same answer we're going to get if we take and we put this, crap. You type this in. So -3 plus the square root of 17 over 2 is going to give me 0.56, okay, which is the same value we got over here, right? But this has to be rounded at some point, and this answer is irrational. So if we want an exact answer, this is our only way to write that, right? And then if we do the minus, we're going to get that other 0 over here, right? But again, this is the correct answer to this question because this is the exact answer, whereas this is just a decimal approximation. If we want the exact answer, which some of your problems in your homework and some of your problems on the test will want the exact answer, we have to stop here. If we write this down, we have to round it. Even though it shows this many decimals, there's an infinite number of additional decimals beyond this. Okay, so if we want the exact answer to a problem like this, we have to use the quadratic formula of the methods we're going to use in this class. All right, so let's do another one. Okay, so let's continue. Let's solve this particular quadratic equation. Okay, so the first thing that jumps out of at me about this problem is it's not in standard form. Remember, if we're going to use the quadratic formula to solve this, we need to have this equation in standard form. In fact, if you're going to factor, you need it in standard form. It's just a good idea if your equation is not in standard form to go ahead and put it into standard form. So really, all I'm going to do here to get started is move the 5x to the other side by subtracting it, right? And then move to the 8 to the other side by adding it. Okay, to cancel all those things out, get a 0 on the right side. That's how we're going to get standard form. And then we'll just bring these down, the x squared, the x, and the constant term. By the way, this has this order. You don't have to write these in this order, but it's called descending order, and it's probably the most useful way to write them. So I would recommend doing that here. But yeah, that's our first step if we're going to solve these things, especially with the quadratic formula. We want to put them into standard form. Okay, next step is to get our a, b, and c values. So my a is 1. The coefficient on the x squared is 1. My b is -5. And my c is 8. Okay. So I'm going to go ahead and put this stuff into my quadratic formula. Okay, so we want the opposite of b. So the opposite of -5 is 5. Again, make sure you're putting this on top of your fraction bar. Plus or minus, we're going to have a big square root of b squared. If you do not put this -5 in parentheses, you will get the wrong answer when you put this into Desmos. So this is not an option for this one. You have to put that negative sign in parentheses or you'll get a different value. Okay, -4 times a is 1 times c is 8. Okay, all over 2 times a, which is 1. Okay, so good setup. So next, I'm going to go ahead and take this value underneath the square root, I'm going to work it out. So if I was to do I'll just do it up here, -5 squared minus 4 times 1 times 8. I could just throw it into Desmos if I want, but I'm just going to work it out here. -5 squared is 25. This should always be positive, by the way. -4 times 1 times 8. -4 times 8 is -32. Put those together, we get -7. Okay, so this is something that will happen sometimes when we're solving these particular kinds of problems. Okay, but this should kind of set off a little bit of an alarm bell in your brain. Okay, because you can't do this. You cannot take the square root of a negative number, right? Because we're looking for something that we square to give us this value inside here. There are no real numbers that do that, right? You know, positive times positive gives us a positive, negative times negative gives us a positive. You cannot take the square root of a negative number. So as soon as you do this calculation, you do this stuff that's underneath the radical, and you get a negative answer like we did here, that tells us right away there are no real solutions to this problem. And we've already talked about how this is a real possibility with these kinds of problems, right? We're asking where this crosses the x-axis, and if we go and we look at the graph, okay, went ahead and put that equation in there. Where is this thing going to cross the x-axis? It just isn't, right? So this is a very real possibility when we're dealing with these kinds of problems that we just don't have any solutions to where our equation is equal to 0. It just never crosses the x-axis. So we want to be prepared for that situation as well. Okay. All right. So let's talk a little bit more about how we recognize whether there are solutions or not. Okay. So this thing underneath the square root here, this b squared minus 4ac calculation that we've been doing has a name. It's called the discriminant for our quadratic equation. Discriminant. Let's see if I can spell this correctly. Discriminant. Okay. And if we can just calculate the discriminant, that will tell us the nature of our solutions. Okay, and there's 3 possibilities here. And we've seen 2 of them, right? Up here in this first one, we did our b squared minus 4ac, we got positive 17. Okay, and so if that gave us those two solutions. And this is kind of universally true. Anytime we do that b squared minus 4ac and we get a positive number, something that's bigger than 0, then every single time we're going to have two real solutions. Now, they might be nice, they might have radicals in them, but there are going to be two real solutions. Our graph is going to cross the x-axis twice. Okay? In our second one, we did our calculation, our discriminant calculation, and we got a negative number. Okay? And that'll happen pretty often. When we do that calculation, if we get something that's less than 0, then that means we're going to have no real solutions to our problem. Okay. Now, the last thing is a little bit of a rarer case, but it will happen sometimes. If our discriminant is equal to 0, this will happen sometimes, then that is the case where we have one real solution. Okay, that means our graph is, approaching the x-axis. It's touching it, but it's not crossing it. Okay. And so just by doing this little quick calculation, this b squared minus 4ac calculation, we can quickly determine kind of the nature of our solutions. If it's positive, we have two real solutions. The graph is going to cross the x-axis twice. If it's negative, we have no real solutions. It's just never going to hit the x-axis. And if it's equal to 0, we're going to have one real solution. We're going to touch and turn when we hit that x-axis there. So discriminant can be useful for determining the nature of our solutions. Okay, so let's look at a couple of applications of how we can use these techniques to solve these kinds of equations. So this time we're running a company. Let's say we're selling, let's not do units. Let's say we're selling TVs. Okay, so we're a company that sells TVs. Okay, and we have two equations that kind of model our TV sales. Okay, R of X is our revenue equation. And revenue is a business term that describes how much money you're bringing in. Okay. And usually our revenue equations are quite simple, especially if we're a small company, right? Because we generally generate revenue one way. We generate revenue by selling our product, right? So this is a pretty typical revenue equation for a small company, right? We're basically selling our TVs for $445 a piece, right? So we calculate our total revenue by taking that $445, we multiply it times the number of TVs that we produce and sell. Okay. Over here, we have a cost equation. Costs are typically more complicated. There's just more that goes into them because, sometimes you get discounts for buying more. Sometimes there's just a lot more things that can go into a cost equation. Okay, so that's where our quadratic part is going to come from here. So the first thing I want to do is I want to try to write a profit equation for this company. Okay, so what does the profit mean? Well, the profit of a company is the amount of money they bring in, which is our revenue, minus the amount of money they send out, which is their costs. Okay. And profit can be positive, which is good. It means you're making money, or negative because you could lose money as a business as well. So this is an important thing for us to be able to do. I'm going to call my profit equation P of X, and we calculate P of X by taking our revenue, the amount of money we bring in, and subtracting off our cost equation, okay, which is our C of X. So the amount in minus the amount out is how we calculated the profit, okay? So let's do that with our equations here. Now, it is pretty important when you put your functions together to put them in parentheses. The first one doesn't really matter because there's nothing in front of it. But when I come to put my cost equation in here, I have to put this in parentheses because in order to get this correct, I'm going to have to take this negative and I'm going to have to distribute it to each term. You can think of it like a -1. Think about multiplying every term in there by -1. Really, it's just going to change all the signs. So this one, nothing happens. There's nothing in front of the parentheses. I can just drop those off, but I need to distribute this negative across here in order to get my signs to work out correctly. And then -1 times x squared is -x squared. Okay, I'm going to go ahead and clean this up a little bit. Like I'm going to start by putting it in descending order. I'm going to start with the -x squared out front, right? And then I can put together the 445x minus the 30x, since those are like terms. That's 415x. And then finally, I'll bring down my constant term, which is just that -6,000. And so we've made a profit equation out of this particular problem. Okay, so let's think about this for a second. So what do we know about this profit equation? Well, I know a few things just from looking at the form. This is a quadratic equation. Okay, and my a value is negative. We talked a ton about this last time. That means this is going to be like a U-shaped graph that opens down, right? I also know, just from looking at it, that the y-intercept of this graph is -6,000. That means that if I produce and sell no TVs, I'm going to lose $6,000. That's not ideal. We probably should make some TVs if we're in the TV business, or else we'll just lose a bunch of money for no reason. Okay, so let's use this equation to answer some questions. Let's start by finding the break even point for this company. Okay, so the break even point is kind of the point that means exactly what it sounds like it means. It's the point where you're making as much money as you're spending, right? Where your revenue and your costs are equal. Okay, and so really what that means to us here is this is the point where our profit is equal to 0. Okay, so if I want to find the break-even point, all I'm going to do is I'm going to take my P of X, I'm going to put a 0 into it, and we wind up with a quadratic equation that's in standard form, like we've kind of been used to seeing. Okay, and so we have some options for how to solve this. We can solve it by hand using the quadratic formula, but when I see numbers this big, I don't want to square 415, right? It's just going to give me a very big number. I have to do that in that calculation. This is more of a Desmos problem to me. So that's what I'm going to do. I'm going to take this equation, pop over into Desmos. I'm going to graph it, and I'm going to try to find where it crosses the x-axis. Ugh, my screen is all messed up here. Okay, so let's start by taking this equation and graphing it. So -x squared plus 415x minus 6,000. Okay. And again, you'll notice I see nothing on this particular screen right now. That's because, again, the scale is kind of nonsense. We're going to need to adjust that scale for sure. Okay, so what is our X? Well, our X values are the number of TVs that we produce and sell. You can't sell the negative number of TVs. So we certainly want to set our X min to be 0. And then X max, we're just going to have to kind of guess and check this. I don't know, maybe we'll try like 100 at first and we'll see what this looks like. Okay. It might not be big enough, but then for the Y values, right, I know that if I sell nothing, my profit is -6,000, and then hopefully we can make at least that much money at profit. Nope, looks like that's too small. And this is where I kind of adjust. 6,000 was too small. Maybe I'll try something like, I don't know, maybe 15,000 will look better. Okay. Still looks like it's going much beyond that already. So maybe we go to something like 25,000. That's starting to look a little better. But what jumps out at me now is I still don't see the top of the hill, right? So I should probably adjust this further to the right. I guessed 100. It wasn't big enough. Maybe we try something like 250. Oh, nope, sorry. Maybe like 250, still too small. Maybe I try something like 500, and that looks pretty good. I can see the whole graph. Okay, now I don't see the top of the hill, which I might need later. So maybe I'll adjust this number up a little more. And again, I am not doing anything wrong here by not getting the window right the first time. Nobody gets the window right the first time. Okay, so it's a process that we're going to have to guess and check. Okay, so now remember what question we're trying to answer here is what is the break even point for this particular company. There's actually going to be two break even points, kind of a good one, right? Because usually you start a new business, you start by losing money, right? So we're trying to get to this first break even point as quickly as possible, right? So our company will break even if we sell 15 TVs, right? And then we have kind of the sad break even point over here. We've like over leveraged ourselves. We're selling too much and we're losing money now, right? So if we sell 400, we also break even as well. But this is the good one. This is the one we want to get to as quickly as possible, right? This is the one we never want to get to. We want to stay over here. We want to live in the parts where our profit is as big as possible. Okay. But our break even points here are 15. We break even if we sell 15 TVs. We also break even if we sell 400 TVs, according to our model. Okay. We could also ask, what is the maximum number of TVs that we should sell? Okay. And again, if we want to maximize our profit, that's going to be this point up here. Okay. Now we're talking about a number of TVs. So I would always round this to the nearest whole number. So I would say if we want to maximize our profit, we would want to sell about 208 TVs. And that will maximize our profit at about $37,056. Okay, so we needed to be able to do some of these by hand, but when our numbers get more complicated and messy, like we generally see in business and biology type applications, there's absolutely nothing wrong with solving these kinds of questions with technology. This would be a messy calculation to do by hand. We could certainly do it with the quadratic formula, but there's no real reason to, in my opinion. We can also solve it just by using Desmos and find, and if you're going to use Desmos, though, you have to be able to set your window properly and you have to be able to kind of understand what they're asking you for. The break even points are the points where we cross the x axis. The point where we maximize our profit is going to be the top of the hill point, right? This is the number of units that we sell to maximize our profit. This is our maximum profit value. Okay, so hopefully that's enough to get you off to a good start on lesson 3.2. Okay, again, I'll be around all week. I'm working from home, but I'm still around. I'll be able to answer any questions that you have. Send me an email. Use the Ask My Instructor button. I'll be happy to answer any questions that you have. If anything pops up, please let me know. And we'll see you guys on Tuesday. Oh, I would also expect 2 more videos coming for the next couple of lessons tomorrow because, we just have to do an entire week worth of stuff this week in order to we just don't have time to make it up during class time. So 2 more lessons coming tomorrow. I would try to have 3.1 and 3.2 done this week. Due date will be Friday at midnight. So keep working on those and let me know if you have any questions. Have a good day.